All right, so I work in Google. I mostly work on the internal TypeScript infrastructure team, but I'm part of the bigger Angular team that we have the TypeScript team as part of Angular in Google. So I want to begin by telling you about my Angular journey. And this is something I pulled from the Angular GitHub repo. Basically, around 4 years ago, I submitted the first Angular app in the world. So 4 years ago, there was one single Angular app in the world. That's the Hello World. And I was there. I can tell you it was barely glued together. It had one service, one component, and it was, it's around 200 commits in. We barely got enough of the framework to work for it to show Hello World. 4 years later, we have all of you here today, hopefully building Angular applications or being involved in the Angular community. And it's just so amazing to see, just in 4 years, how far we've gotten and how far, how much you have taken the things we've built and built great things with them. So I want to remind everybody that even this very long journey began with one barely glued together Hello World 4 years ago. So that's how the journey of a lot of software development is. So like I said, I'm primarily focused on internal Google development, and Angular is very popular in Google. And like Matias said, we're very happy with that. We do have other internal frameworks. There are other choices to build front ends. But what I can say is Angular is the most popular one, meaning the most developers in Google, the most front-end developers in Google use Angular. So these are some Google products that maybe you've heard of or you're using, Firebase, Analytics, Shopping Express, and Cloud, that are built on Angular. And in fact, Cloud, a big part of Cloud is built basically 5 minutes from here. We have a big Warsaw office that I don't know how many of you know about. We were there yesterday with Matias. Actually, do we have somebody here from the Google Warsaw office? Yeah, there are a few of them are here. They told me they're hiring, so if you want to be part of the Google Cloud journey, go meet them in the hallways during the break. So that's right, Cloud is using Angular, and it's quite a big application built using Angular. We do have a very long tail of small internal applications too. So we have 600 other applications you never heard of. A lot of them are kind of internally facing, but Google is a big company. We have a lot of variety in the front ends people are building. So one great collaboration with Google Cloud that I'm very excited about is Google Co-Design. So this is a tool for prototypers and designers to prototype Angular applications, which lets you use real Angular components, but in a kind of drag and drop format without having to write any real code. This is something that we think will be available for everybody to try early next year. Again, we're working in collaboration with Google Cloud on that, and basically we're very excited to bring more of the designers and prototypers into the community and don't force them to write all this code and use all this tooling that software engineers have to work with, and could be quite intimidating. So this is a tool that does not require you to write any code to get a prototype of a UI ready. And we'll hear more about the designer-developer collaboration later today. There's a talk by Grzegorz who happened at 2:45. All right, so Angular at scale, like I said, in Google, we do have these kind of big Angular applications. How do we make Angular scale? What are the secret weapons? Well, they're not very secret. We have a talk about it by Manfred at 3:55. But I can tell you specifically for Google, the tricks of the trade for scaling up is rely on tooling. We have some really great tools in JavaScript, and one of them is TypeScript. This is close to my heart. That's what kind of I work on. TypeScript is Angular has been using TypeScript since day one, basically, or day two maybe. But Angular and TypeScript are very well integrated. Angular is built to support TypeScript. And in Google, how do we scale TypeScript up? We rely on, for example, TypeScript is a very configurable compiler. We rely on the most strict compiler flags, -- strict. We use a single compiler version for every product in Google uses one single version of the compiler. That sounds kind of crazy and hard to do, but we do it. How do we do it? By using a lot of automated migrations. We have this monorepo, so all the code is visible to us, and we go and migrate everybody's project to the single compiler, and that gives us amazing opportunities. Like if you work on one product in Google, you can take your TypeScript code and put it in another product, and you just compile. There's no difference because the compiler is the same. And finally, we make heavy use of TS-lint and a style guide. So for the style guide, every style rule we have, we try to write, not all of them are possible, but we try to write a TS-lint rule to enforce the style guide. So if you're excited about TypeScript, Todd is going to come on stage right after me and talk a lot more about TypeScript. But again, this is one of the tools that make the Angular application scale up. The other tool that we use heavily in Google, and again, it's open source and all of you can use it, it's Bazel. So Bazel is a build system that it's fast and it scales. It allows us to build, basically take any compiler out there, be it TypeScript, Java, C, C++, and use Bazel to orchestrate the compilation across all the front ends, back ends, and any type of software you have in your organization. That creates some amazing opportunities, like, for example, changing the data format of your front-end, back-end interop, pressing a button, finding all the front-end and back-end tests that need to be run, executing them all, and all of that being automated by Bazel. And also Bazel brings this robust incrementality, meaning the rebuild step is always when you touch the file, what has to be rebuilt is always the most minimal thing. If I touch one file, only the thing that dependent on that file gets rebuilt. So that's how you get fast compilations for a very, very large project, like some of the projects we have. Angular and Bazel, we've been working on having very nice support for that for almost a year now. So it's technically still in labs, but we're getting very close to launching this. We're accepting early access. So if you're in a big, you have a very big Angular application, please come talk to me after this. And we've made Angular itself on GitHub use Bazel, so you can see how it looks like. And this is very soon coming to the CLI, meaning very soon the CLI will have a special flag, and you press create a project with the right flag, and it would have the Bazel built behind the scenes instead of the current setup. Some other talks about tooling. We'll hear Aaron talk about Prettier, which is a code formatter tool, and we'll have a talk from Piotr about WebStorm. So tools are very important in the Angular ecosystem, and that's what they help us scale our Angular applications. All right, so that's where we are today. Angular tomorrow. So what's next for us? We're, like Matias had, we're pretty happy with the stability of the API. We're very happy with the way Angular works. What we're really working hard on is making it smaller, faster, and easier underneath the hood. So we're putting a lot of effort on optimizing things and doing it in a way that's stable for you. So your applications can just stay the same, but be more performant on different metrics. So this is where we sit. We see Angular sitting here. On one side, we have these very large industry-straight enterprise applications that we want to serve them well. But also on the other side, we do have this more website-y, lightweight use cases of Angular, and we do want to serve those too. And when you try to do something more lightweight, there's different set of techniques and tools you want to use. We have some things that we've worked on in the past for a more lightweight Angular experience. One of them is Angular Universal. Angular Universal is a server-side rendering solution for Angular. We do support optimization and lazy loading. That's a nice way to let parts of the application be loaded later, and having the first paint in the browser be a lot faster, especially for mobile. And we have two other exciting things that I'll talk about in a second, which are Angular Elements and Ivy Renderer. If you want to know about lazy loading and dynamic components, we have 2 talks today about that, so you'll hear a lot more by Niemelä and by Martin. All right, Angular Elements. So this is a new initiative kind of in the last few months, but we have launched it. Angular Elements is a way to take one Angular component or like a subset of your application and wrap it in standards-based web components and put this Angular widget or mini application in an environment that is not Angular. So that's kind of the interop bridge into some other environment that, maybe you have to embed Angular in a place where there's no Angular, in a static site or so on. Angular Elements is a great way to do so. It's self-bootstrapping, standards-based, and it is available right now. If you go on Angular.io, we have documentation how to use Angular Elements, and they're this great bridge into other non-Angular environments. And finally, Angular Ivy. So this is the new renderer that we're working on, the new compiler and renderer behind the scenes. So behind the thing you write with Angular, the add component and so on, there's a big machinery that you don't see. But we're working very hard on optimizing it and changing it to be smaller, be faster for compilation, and to be that simple for debugging. We've been working on this for a while, and we'll see in a second how close we are. One way to think about it is, maybe you heard these words, like we have these 2 compilers in Angular. We have the AOT and the JIT compiler. And they all sound great and also not so great, depending on what you look at. So the AOT compiler is the static compiler. That's the one that takes the template that you write, this HTML, and outputs some JavaScript statically before you run in the browser. So you do this as part of your build. When you've done that, that code is optimizable. It's seen by your optimizers, and you can do all these amazing optimizations on that generated code. In JIT, everything's happening in the browser. It's dynamic, so you can auto-optimize it, but at the same time, you don't need to have this complicated build step. So it's this trade-off on both sides, and on the flip side, so if you do AOT, that means the compiler, you run it during build time, so you don't need to ship it to the client. So that's less code that you need to send to your users. In JIT, you have to ship the compiler to the browser because it has to run actually as the user is loading the application. The similar story for NPM, the AOT code being generated cannot be sent to NPM because the way it's built right now. For JIT, there's no such issue because you can take a template and put it on NPM. So basically, they're both great, but for different reasons. And we looked into this, and what Ivy is trying to do is kind of really bridge the gap between these 2 compilers, because you really want both, right? You don't want to pick and choose. And Ivy manages to really, there still will be AOT in JIT, but the difference will be a lot smaller. So you'll get some of the benefits from JIT in AOT, and vice versa. So one of the main benefits of Ivy is you don't pay for what you don't use. So we live in this world of JS optimizers. I think everybody here is probably using one of those, and if you're not, you should be. Our code is always running through some extra step to take your JavaScript and remove the parts that are not needed, minify it, and so on. Really try to make the smallest bundle that we send over the wire, because that's what makes the user experience a lot better. So historically, the generated code with AOT was not built so much with optimization in mind, and what Ivy is completely changing it. The Ivy generated code is very amenable to static analysis and to optimization. So Ivy generated code can be analyzed by basically any of those JS optimizers, and they can really understand what's happening and strip the parts that are not needed. So not only the application, but the framework itself could be completely understood, and the parts that you don't use get removed, because the framework actually has a lot of features, and if you don't use them, the optimizers will remove it, and you get the best bundle you want. So for example, if you do not use content projection, with the current setup, there's still a little bit of code that's shipped to every single browser, just in case there's content projection. And the way it's set up is the optimizer cannot remove that piece of code because it just doesn't statically understand what's happening. With the new Ivy code, you do not use content projection, you do not pay for it. You do not use internationalization, you do not pay for it. You do not use view queries, you do not pay for it. So really, the bundle can really, really shrink down. So to show you that this is, this happened, Brad Green, our manager, kind of the person running the whole Angular project, he's a baker, so he likes to bake, and he's an amazing baker. He said he'll bake a cake for us if we get the hello world, which is like the smallest possible application below 10K. And previously that was not possible. Without Ivy, it's 36K because even the best we could do before no zone, every trick we had in the book was still 36K because of what I said, right? There are all these bits baked into the runtime in case you've used content projection, let's say. And hello world doesn't use any of that, but it was kept. We had to rethink the compiler, we had to rethink the code generation, but with Ivy, we not only hit this goal, we hit it quite, we got our cake and more. With Ivy, the hello world minified was 7K, and with compression, with Broadly or gzip, it's already down to 2.7K. So again, this is a very tiny hello world, so your applications will not be this small, but what's very exciting for us, this shows us that really every single piece could be tree shaken away, could be removed because it is not used. So it's nice to have this extreme point, knowing that there's nothing that stays if you do not use it, and that gives us a certain nice certainty. So we're very happy about this metric. And just to wrap up about Ivy, so Ivy does some great optimizations with the code size. When we were rethinking a lot of the internals, code size is not the only metric we're looking at. Memory usage is also very important. That's something that can really slow down the performance of applications. And with Ivy, according to some metric we have, we really rethought a lot of the memory layout of objects, and we redesigned it to have a lot smaller memory footprint in the browser. And again, all this is to say that we're using Ivy as an initiative to improve a lot of the internals of the compiler while keeping the external API exactly the same. So there's no planned changes in the APIs you're using. What we're hoping is when we deliver Ivy, your applications just become automatically faster, more performant, without breaking anything. And so, okay, that's great. How do we know this is going to be the case? Well, again, we're sitting on these 600 applications, including these giant 4 ones here in Google. And what we're doing is, before we give it to all of you to try it, we're trying to make sure that it works for them. And then, that's how we're validating that Ivy really works and it's really backwards compatible, and every bug we find, we go back and we fix it. So we think feature-wise, Ivy is built. So this is the timeline, this is where we're standing. Feature-wise, we're trying to validate it, verify it with all the applications internally in Google, and we do have a lot of them. This is a long process, so today we're kind of at the beginning of it. Well, at some point in the middle of it, we're going to announce Ivy available as a labs, what Matias said. We have this labs initiative. And hopefully within a few months further, we'll have a general release of Ivy. That's all I had to say. And if you want to... Oh, yeah.
Welcome to ngPoland.
Welcome.